Hey everyone, welcome back to the 443 Security Simplified, live and in person, I guess not live, recorded, but in person edition. I'm your host, Mark the Liberty, and joining me today is
Corey, Session Cookie Monster, nom 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 nom, Knockreiner.
Okay. If you haven't already noticed, we are coming to you from WatchGuard's Apogee Partner event for 2024. And today we're going to be discussing a few different stories, actually not related to the partner event, but hey, it got Corey and I in the same room together, which is kind of cool. We're going to start, or I guess end, with what Corey just hinted at, a way to potentially save the world from session cookie theft. Before that, we'll go into a pretty serious vulnerability in a popular VPN appliance, or VPN feature in a popular firewall appliance. And then we'll start with a discussion around how to secure artificial intelligence deployments.
Yeah, thanks to the U.S. federal government and a whole lot of other intelligence agencies around the world. Woohoo! Intelligence agencies.
I love taking security advice from the NSA, that's for sure.
Oh, yeah.
Anyways.
I do like the NSA. We love you, but I do cringe a little as you say that.
Hey guys, use this algorithm.
Yes. This cryptography is really strong, except for when we have the key.
Anyways, let's munch our way in.
Yeah. Nom 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 nom.
So let's start our first story today with an update on, I think, our favorite topic on the podcast, right?
Maybe, but we don't like buzzwords here, do we, Mark?
We don't, but because this
is an interesting topic, though.
Since we're not writing it in code, we can call it artificial intelligence right now.
Okay.
And just this last week, Corey and I, we both got an email from the FBI. We signed up for, advisory alerts from them and CISA as well.
Yeah.
And this advisory, I guess maybe not advisory, like white paper came out.
Yeah.
Co-branded from the NSA, the Cybersecurity Infrastructure and Security Agency, the FBI, all of the Five Eyes intelligence and security organizations.
Australia Cybersecurity Center and the NCSC. I always mess up the UK one.
NCSC from the GCHQ.
Yeah, there you go. And I think it's called a Joint Cybersecurity Information.
There we go.
And they just cut it off at information, but yeah.
I'm going to call it a white paper.
Yeah,
anyways,
that's what it is.
They just published and provided a white paper on the topic of securely deploying and managing AI-based systems in organizations. And it's primarily targeted, they note in the first couple of paragraphs, like who the consumer of this white paper should be. They said it's targeted towards primarily organizations that are deploying and operating externally developed AI systems.
Yeah. But it's still local ones, so it's externally developed, so it's not your own. But it sounds like it's more downloading tools and frameworks that you control on your infrastructure. It's not necessarily, there's lots of AI platforms that are essentially SaaS apps, right? ChatGPT. And you can use that tool. It's an external tool, but that's not in your organization, so you really can't protect that. But this is a framework you'd download. Would TensorFlow count, or is TensorFlow only in the cloud?
You can run it locally, as long as you've got a sufficiently beefed up computer or a couple of Google Corral chips.
So anything you're downloading and you're running on NVIDIA GPUs or something, how would you protect that?
Yeah. So basically, like you said, anything you would deploy on-prem or like in a cloud environment that you manage. Yeah. But they boiled this whole report down. It's like 20-something pages, I think, into a few main sections. So like how you secure the deployment environment, how you continuously protect that AI system, and then how you secure just its overall operation and maintenance. And they basically give, it's pretty high level, but at least interesting tips that it's one of those where, like you and I talked about this earlier before this episode, where they're not like groundbreaking, they're kind of high level, but it's things where like if you and I were sitting there trying to think about how we're going to secure this new AI thing.
Yeah. When I say some of the tips are like this, my surprise is, we'll get into the detail, I think, but some of the tips were semi-generic in that it's how you'd protect any network service that had inputs that potentially you were exposing somewhere. But there were a few of the tips that were very specific to AI systems. So I found those tips more interesting. But let's get into it. What were some of the tips?
So they start with where everyone should start with security, which is governance.
Yeah.
And so when it comes to setting up that deployment environment, first just laying the ground rules for how your organization will manage risk around it, whether this AI system, this unnamed system, is appropriate for your organization based off your risk. Like I like that they started with that. It felt like a good place to, like, something a lot of people would probably skip over and go straight into how do we use it instead of should we use it.
But this is the first thing you should do with any new technology is create a risk profile for it, figure out what are the potential threats to it. And security doesn't want to be a barrier to businesses using new and cool and innovative tools. But how can you protect something unless you have a policy where you've decided what your risk appetite for the technologies that might have different types of risk impacts depending on what the technology is. So,
They go into some specifics. So like identifying who the stakeholders are, figuring out a threat model for it they recommend from the vendor getting that so that you can understand how you would need to protect the system too. And making sure you're considering security requirements when you're like making the contracts for these as well. All decent tips.
Although so far, that could be generic to anything you were bringing into your network so far.
Yeah, 100%. It does seem like a decent amount of technology agnostic tips in here, which is
But
fine.
I don't mind. A lot of people don't know the one-on-one. A lot of people don't have a framework to go through this, so it's still good advice.
The next tip they had was ensuring a robust deployment environment architecture, so how you design where you're going to place this, looking for blind spots based off the trust model. And the final tip of just applying zero trust principles, which again isn't AI specific, but something you absolutely should consider when you're protecting any system, regardless of if it's powered by Bing or ChatGPT or not. When it comes to continuously protecting the system, they talk about things like validating it, so making sure that you can confirm the integrity of the system, that it's not being tampered with while you're using it. They recommend things like cryptographic hashing it, maintaining copies of previous releases that you can compare to as well.
That is this is, to me, it's targeted more at CISOs though, because I know I'm a CISO essentially, but I immediately like that's cool. Again, it's a generic tip though, so in an AI subset, like if we're downloading these AI frameworks to create our own AI tools, what are the specific files? What is it that we need to integrity check? Where is the data? And those are questions, I guess, that it depends on what AI framework or product you're using to help you create whatever model you are. But they're not really getting into the nitty-gritty of the details of these AI systems. Like, is it the data set, which could be many, many different files that the AI system's pulling from a folder? Are you supposed to integrity check and confirm all that to make sure your models aren't poisoned by something? Or is there some file specific to the AI platform? I mean, again, good generic, any network service you have, like if you have an IS, even at the very least, the executable for a server, make sure it hits an integrity check. It's the right MD5 or SHA-2 hash of whatever system you downloaded. But it still didn't feel very specific to AI to me yet.
Yeah. They also recommend some things like hardening the deployment environment itself in its config. So like use a sandbox, like hardened containers, instead of just plopping it on your Windows 11 machine or whatever that's totally joined to the domain. That makes sense too. They recommend things like strong access controls and authentication, MFA to access it. A lot of AI systems, in fact, a lot of all technology these days has APIs available to programmatically interact with it. They cover what you should do to secure those APIs and access to the APIs also. Some general cybersecurity tips, again, of just collect logs and make sure that you can review logs for unauthorized use or tampering. One thing that did stand out to me, though, that is specific to AI is they even had sections on like protecting the model weights. And so if you're not familiar with machine learning or artificial intelligence, they're basically designed to take in something, discover or pull out features. So for example, the size of a picture or the amount of blue pixels on the picture, things that like
sometimes not things humans would even think about.
Correct.
But,
and then based off those, it ultimately makes a decision on what it is, and that can be tuned with different weights. Like, how much do I weight the file size of the thing versus the number of letter A's in the text or something? And they recommend specifically like paying attention to that, and that training data, or the data that's been trained in the model, protecting that too from potential tampering or even exfiltration out of the organization. Why do you think that is?
Well, so I thought that was great, because if you know those weights, you might be able to game the AI model. So we've talked about adversarial machine learning before. And I feel like there's two ways to attack it, and I'm not sure if they talked about the inputs and the outputs of the system. So the weights, to me, are that file that really is the model. You definitely want to directly protect that, because if someone gets that, they kind of know the weighting of the features for the model. So if I'm trying to design something that is going to trick it, I know what features to pay attention to. And especially if I have those weights and I have another ML model, I can probably help. That will help me really train my AI model quicker. But the other thing I always think about with AI, and it depends how you deploy it, but is it a publicly accessible input where an external user can upload something to get the we always use image analysis. Say you have an upload tool that it will tell you what the image is, and there's a machine learning model to do that. So that's the input for you. That means the threat actor can put whatever image they want and know what the input is. And then, obviously, if you have public AI, there's an output where you say, oh, I believe this is a duck, and the AI model had a 92% confidence rating. If you expose that crap, even with that, you can learn the weights kind of brute force. An AI model could upload billions of pictures and look at what the result was, and AI could kind of reverse those weights.
Or you could save time and just export them.
Well, that's what I was going to say. I love that they protect the file directly. So that is the thing to protect more importantly, because you don't want them to just export them. But they didn't really in this talk about inputs and outputs of the AI model.
They didn't, no. Like they also have recommendations around protecting access to it.
That is true.
Like
maybe that
counts. Role-based access.
If it's an authenticated one where you're not making it public, maybe it's less an issue.
Yeah. And then like finally rounding out a few more hopefully obvious ones, things like having good patch management and updating it regularly. Regular audits and penetration testing to confirm your security controls around it, and setting it up in a way that maintains high availability and your ability to recover from a disaster if it's important enough to your business too.
Cybersecurity, resiliency, I think is a new buzzword.
Resiliency.
For that. Yeah.
So either way, like if you are considering deploying a artificial intelligence system, like I feel like it's a good checklist to go through.
Oh, it's absolutely
a
good
checklist. Save you some time of brainstorming to figure out on your own what you might need, but very like high level starting point, not a in the weeds like how to do everything kind of thing.
By the way, I love that FBI and CISA and all the organizations are doing this type of hardening guide, and education is great for the community. But if I'm devil's advocate too, that what I was disappointed about is if I'm downloading a framework, it basically told me how to protect it. But at the end of the day, it could have been the 101 on how to protect anything except for the weighting.
Yeah.
But my bigger issue is they don't talk I hope they release a document. Why should you be using a local downloadable one versus some public thing that you can do in the SaaS? Because I think a lot of people want to know the risks of
something around like data security and data privacy.
Yeah. We've talked about what the risks are ourselves, but hey, how do I protect myself if I'm using one of the freely available SaaS applications that every employee is finding on their own and going to? This is the better model for a business if you download something and have control of it, and you only need the AI model to do something for your product, your service, whatever it is internally. More secure, especially if you follow this hardening guide. But I think the bigger problem in AI right now is shadow AI, is the fact that anyone at my organization sees the power and efficiency of some publicly available tool. So I like this guide, but it didn't. I feel like the bigger risk is not this, and actually, for the most part, hardening the on-site version seemed pretty easy to me. I probably would have figured out the weighted thing too. Yeah, of course, that's the file I want to integrity check the most and protect from getting out there. But still a great guide. I mean, everyone needs, there's so many people don't follow these type of frameworks at all now. So having another place that's giving them a good checklist is good.
They got to start somewhere, I think. This won't be the last bit of guidance, I bet.
Probably not.
AI management, so.
The government has clearly kind of pointed out that even though they probably use it a lot themselves, that they're a little scared of AI right now. There was some CISA releases talking about the risks, like AI being a significant risk in the past.
Because remember, the primary consumer of like this type of report is technically, critical infrastructure and government agencies that might be using it. And CISA. So it's good they're getting it out ahead of potential, like every organization adopting it tomorrow kind of thing.
Exactly. Yeah.
So either way, good starting point.
Yeah.
And thank you again, CISA, for another great white paper on how to protect us from ourselves. So moving on, the second story today. This started on April 12th, where Palo Alto disclosed CVE 2024-3400, which was a 10 out of 10 CVSS scored vulnerability. Not fun.
I like 10 out of 10 on my report cards, but you don't want 10 out of 10 when it comes to CVSS.
Unfortunately not.
By the way, I think we should jump in here that we want to talk about this vulnerability because it's interesting. But Palo Alto technically could be a competitor of the vendor we work for, but we have everyone has vulnerabilities. We've had vulnerabilities, so we'll talk about this frankly, but no shade against a competitor, even though they are a competitor.
Yep. Yeah. Again, like to reiterate what you just said. Everyone can and will have vulnerabilities. So not throwing stones. It's just, this is an interesting one.
Absolutely.
And so it's a unauthenticated remote code execution vulnerability in the Global Protect VPN component of their Palo Alto OS firewalls. Basically, if you turn on the remote access VPN, that could allow a unauthenticated attacker to gain code execution on the firewall itself.
And it's worth stopping there just to bear the repeating of VPN, remote access.
It's designed to be exposed to the internet.
Yeah, we've been hammering this, even looking at our own products this way, but the Pulse Secure, FortiGate, all kinds of other types of remote they're targeted right now, and they specifically seem to be targeted by state-sponsored actors too, which I'm sure we'll get into.
Exactly. And so during their disclosure, they noted it was under active exploitation by threat actors in the wild. We'll get into at least like one story about one specific threat actor going into it later. But the proof of concept code for it apparently has been floating around for quite some time too on like underground Telegram channels.
Oh, wow.
We found it when it showed up on a Twitter post sometime last week.
Yeah.
And
this is circa 1990s web stuff, man. I'm sorry to say. By the way, again, no shade, but this was a surprisingly simple attack.
It was. So it looked like it was some form of what's called a path traversal vulnerability, where, on like a Linux or even Windows-based operating system, you can take shortcuts when you're trying to move around through directories by using / to go back one directory. You can go all the way back to your system root by doing /
Yeah.
And web applications like a VPN aggregator or VPN interface or a management interface, they're designed to be kind of contained within a web root directory. Like, you can only retrieve web files from that directory. You shouldn't be able to save anything out of it.
You shouldn't be able to do a directory traversal attack.
Correct. But in this case, it looked like through the session ID parameter of the cookie header. So how you would typically, your browser would say, I've already authenticated, here's my session ID, and you could rejoin a session. The proof of concept was this path traversal through there, where they can point to a telemetry log located in another directory somewhere on there. And then they would abuse the file name of that telemetry log to basically, it's pretty simple. They set a variable in bash, just like normal command line stuff, decoded that variable, so piped it to that, and then piped it to just a bash command to execute that variable. Pretty simple. And at some point later, so it's actually not a instantaneous exploit, it's when the telemetry system behind the scenes goes to collect up these files.
It's like a log type of one. If you think about weird ways you can get input in a system, obviously anytime a user can put input in a system, there's a potential risk.
Yep.
Maybe you're not directly inputting in a system, you're just generating a log. But what's really interesting about that is eventually another system might parse that log for something, and thus what you're going to get to, I'm sure.
continuing down that tangent, like to give an example of that, on the Firebox, quite a while ago, I think it was probably 5 or 6 years ago now, there was a cross-site scripting vulnerability through the username parameter in our login logs. So basically, to exploit this vulnerability, you would put JavaScript code as your username, go fail a login to the box. It would save a log saying script whatever alert whatever failed to authenticate. And when you open that up in the web UI, it would trigger a cross-site scripting because it would evaluate that
alert.
Script. And these are
or something worse, by the way. Alert's just a typical way to demo cross-site.
And so there's
scripting.
clever ways to abuse systems like that on devices. And in this case, it looked like there's some logging component, something of their telemetry system, where sometime later it would go and parse that file. It presumably would take the file name and try and pull parameters out of it, maybe to package it all up before sending it to their telemetry servers. And as it was doing that, it would execute the file name in there and will somehow execute that malicious code they had put in the file name there. It's not immediately obvious like why the session ID parameter was the injection point, because I can't think of like why you could save it into a file, like why that would need to be necessary. Anyways.
Weird.
But so at the time of this recording, they have at least mitigated it on almost all firmware releases. It's taken a little bit of time, but they've been releasing over the past few days mitigations for their most popular or most widely used releases, all the way down to other branches and other patch levels too. But so there was an article by Ars Technica we saw too, with your favorite author as the one that wrote it, saying that a quote-unquote capable actor, most likely UTA 218, is actually actively exploiting this flaw to deliver a Python-based backdoor onto vulnerable devices.
By the way, pause there. I looked up UTA. It is an APT actor, but what's fascinating to me is it's state sponsored. Velocity, there's another site who might be one of the first people that, like, maybe it has a different APT number for other security companies, but UTA 0218 is associated with this other site. And they say state sponsored everywhere, but they never say the state. And then I read a thing that said currently that is classified. So
interesting.
I'll find the link that I can show you too, but it is state sponsored, but they're not saying Russia, China, US, Iran, who knows what it is. So I just found it interesting that it seems that they believe they know what state it is, but it clearly said they're not, at this time, we're not sharing that.
I'm going to read between the lines and assume it's the United States now.
It could be.
That's interesting. Anyways, that's pure conjecture. Don't know. But interesting point. So the backdoor itself is interesting. So they effectively exploit this flaw to download a Python file to a location wherever they want. Once you gain access to just the bash shell like this exploit gives you, you can do whatever the heck you want on the system as long as there's no integrity verification. But so they download this file called update.py and basically register it as a Python package that will automatically run as other Python functions run on the system. They would interact with it in a pretty interesting way, though. So they basically set up this package to read the web server error logs for the VPN appliance. So like the SSL VPN error.log file. And so they would get commands into it by navigating to a non-existent web page with carefully crafted parameters.
Yeah, I remember.
And this Python script would go review the logs, notice that whatever special web page or special parameters, grab that parameter, decode it, execute it, and then save the results into just a CSS, like a style sheet file that's publicly available on the web server. It's actually one of the legitimate files that would just modify it and stick in the response. So presumably whatever's trying to control it would just periodically ping that, get the responses back, and then 15 seconds later it would go clean up its tracks, delete it from the CSS file, and go delete the log entry for the
pretty nasty way to hide.
Very, very interesting. And that's also like when you can get a arbitrary Python script on like a network security appliance like that, that gives you a lot of power.
Oh, for sure.
So as it stands right now, I guess unknown threat actor, but presumably nation state. The proof of concept code's been floating around forever. And so if you have a Palo Alto device with the VPN enabled, make sure you patch it, because that is the strongest mitigation recommendation right now.
Yeah.
They originally said you could disable device telemetry and that would help, but they retracted that later.
Yeah.
But either way, like an interesting vulnerability to talk about, one that could and will happen to other folks too. And yet another example, like you said, of...
And I can tell you, we've obviously had attacks that you may have heard in the past against us. We really have been focusing on VPN. So besides the general advice we're giving you of patch your devices, I think any other vendors out there of VPN products should really be paying attention to their secure software development lifecycle, because they're being targeted. And it's whoever UA218 is, UAC, or UTA 0218 is.
I'm sorry, what?
Whoever they are, they and other state-sponsored actors are targeting people.
Yeah, and it makes sense. Like, these services are designed to be exposed to the internet, which is a large attack surface then.
Huge.
From all the customer base. And if you can find a flaw like this, suddenly you can expand the breadth of your attack to a whole bunch of different organizations.
Yep.
Pretty nuts. Either way, though, like I said, at the time of this recording, there was only like 2 small firmware releases that hadn't gotten a patch yet. If you've got one of these systems, make sure you go update it. So to close out, there was actually a really interesting post I saw that actually Google published this on their Chromium developer blog several weeks ago, but I just saw it today. And it really stood out to me as no duh, why have we not been doing this for such a long time? So let's get into it. The Chromium developer blog had a post in early April describing the steps that they're taking within Chromium, which is the engine that powers Google Chrome, Microsoft Edge, and like a few other, I think Brave is another one. The steps they're taking to prevent session hijacking attacks that use stolen cookies.
Yep.
So let's pause for a sec and explain session hijacking just in case.
Yeah.
I think we've talked about adversary in the middle attacks a few times on here.
Many times. And even probably explained this like a year ago, but we should do it again.
Yeah. Where basically, let's start with a basic phishing attack where you get a link to a fake login form somewhere. Could pretend to be Microsoft or Google or whatever. You click the link. You're somehow convinced into entering your username and password. You hit OK. You get some generic error message. Oh, we couldn't log you in. Sorry.
Yeah.
Behind the scenes, they're stealing your username and password. And this is how traditional phishing used to work, where they'd get your credentials, then they would go in a different channel, try and actually log in with them to compromise your account.
But Mark, what if I had MFA? I mean, they'd never steal my password, and they'd never be able to get in a website with MFA, right?
Exactly. And that, so
I'm being sarcastic.
But that is with old style phishing where it stopped. If you had MFA, there was nothing they could do. Yes, they had your password, but unless they broke into your house and stole your phone.
I'm also arguing they always could do something with MFA if you look at what you're about to get to.
So the newer style phishing we're seeing, using adversary in the middle technologies, things like Evil Proxy, which was available for sale for licensing on underground forums for a while. Instead of just stealing your username and password, they actually insert themselves as a proxy between you and the legitimate service. So they not only steal your username and password as you log it in, but they forward that on to Microsoft365.com. Microsoft goes, valid username, valid password, prompts for MFA. You on your phone go and accept the MFA prompt because there's no major red flags at this point. And it completes the entire authentication. And in the middle...
Wait, after I authenticate, I'm not just going to leave the site. So why don't I have to authenticate over and over as I'm browsing?
Because at the very end of all of this, you get what's called a session cookie, which is basically a little bit of identifier, like a bunch of text, randomly generated code that the web server provides back to the browser. Your browser saves it locally. So now every time you go to that page or refresh the page or navigate around on that site, your browser will automatically provide that to the web server, and the server goes, 1, 2, 3, 4, 5, that's Corey Knockreiner. He authenticated yesterday.
Yep.
And that is how you can navigate around.
By the way, he says yesterday. I hope that most session cookies have maybe a 12 to 8 hour, even less would be good. Banks probably should only have like a 5-minute session cookie before it expires. It should expire. One protection against what we're talking about, get that guy to expire, and at least it's less useful to the attacker. But you say, I logged in yesterday. there are sites like social media sites where the session cookie like seems to last. I haven't found out for sure what Facebook uses, but I don't think I have logged into Facebook for a long time. So I feel like there's a lot of long-lived session cookies out there.
So it gets a little more technical than just a piece of data returned to you. Yeah. Most websites these days operate with a refresh and an access token.
Gotcha, yeah.
Where you're given two pieces of data, a access token that is what you provide to prove your identity, and a refresh token to periodically refresh that access
so you don't
token.
have to keep logging on. Yeah.
Exactly. And so the access token is a short expiration, so that if it gets stolen, it's only valid for 5 minutes and it can't be used again. The refresh token, which in theory should rarely leave your computer, would allow you to get a new access token.
Gotcha.
So one of the common ways we're seeing these things stolen now is those adversary in the middle attacks. It doesn't even have to be that sophisticated, though. Malware these days can go just yank it straight off your computer, too.
Outside your browser's store of them.
Because, for example, Google stores all of your session information in just a file, an encrypted, SQLite database. It's like a little mini SQL database locally. It encrypts it, but the encryption key is also local that it can use it. And so it's relatively trivial for malware on a computer to go steal all your session cookies.
Yeah.
And so once an attacker gets a hold of those, they can just assume your identity with that application.
They don't need to log in again. They don't need the MFA again. It's all there.
Exactly.
Before we get into the cool stuff, we have talked about protections for this before, and there are some, but I feel like they're imperfect and they're site-specific. So some things that have been tried, and we'll probably go deeper into the cool new thing, is if I'm a bank and I know session hijacking exists, I'm going to want to do more behavioral analysis of the people connecting to my site. And there's lots of stuff they get from your HTTP, your client headers, the actual all the different things that are sent when your browser connects to a server.
They fingerprint it.
In fingerprinting, they can use the user agent header to at least figure exactly what browser you're using. They might even be able to find out what kind of device you're using, maybe not in a very strong way. And then they'll just tie that session cookie to that particular browser only, so the hacker would have to not come from a different browser when they used. And there's other little things they could do, but the problem with that is that's each individual website owner has to figure out how much more checks they're going to do, and things like the device identification is not as you're making fingerprinting guesses when you're just looking at a bunch of headers that are coming.
And as another example, the most basic form of that is you bind it to the IP address. So I log in from home, so you've got my public IP associated with my Comcast router at home.
Yeah.
And it goes, okay, if this session has used any other IP
address,
then we don't allow it.
Do something.
It was 2 weeks ago we talked about a Chinese-based threat actor,
yeah,
where they would go and compromise the user's home router on the internet.
Yep.
So they can use that as a proxy and get around that potentially as a protection too.
Yeah. So there's little protections, but so far they've kind of been imperfect.
Yeah.
But
and so there was a quote in here. So they go, because of the way cookies and operating systems interact, primarily on desktop operating systems, Chrome and other browsers cannot protect them against malware that has the same level of access as the browser itself.
Yep.
So this is the issue that they're trying to solve then. So they're prototyping what they're calling now device-bound session credentials, or DBSCs.
Just what we need. Yep, another acronym.
Someone just got promoted.
Yeah.
Which they say it, quote, aims to disrupt the cookie theft industry since these cookies will no longer have any value. So it's an API interface where a web browser and a web server can now interact with each other. And it allows a web server to start a new session with a specific browser on a specific device. And it does that by generating a public and private key pair. So when I log into WatchGuard.com, WatchGuard.com would go, okay, Mr. Firefox browser, go generate, I guess not Firefox because it's not Chromium, but anyways, bear with me. Generate a public and private key.
That's a good topic for the end, though. Keep going.
Yeah. And then it would use built-in operating system capabilities like TPMs, Trusted Platform Modules, to securely store that key in a way that you can't easily yank it out.
Yeah.
So instead of just that plain text file somewhere in the Chrome app data directory, it's now using the hardware.
In a secure enclave that's literally in the chip of the computer you're using.
Exactly. And so then your browser would use that public key or the private key to verify it's associated with the public key. and it would use that to then get a new session, a very short-lived session cookie, as it's interacting with the website. So
and I was saying how things like IP address and maybe seeing someone's Safari is a very soft way to figure out what a device is. This is literally your two Apple computers that may be exactly the same would not have the same the key. It's literally a individual key to that one device.
And it's a individual key to that device in that browser in that session. Every other session generates a brand new key, cycles through it. So they said they're also looking at software isolation options too, because TPMs are becoming more popular. Windows 11, it's a requirement. So that's kind of helped, but still a lot of people are using old as crap laptops and they may not have access to that. There's another reason, I'll get into it later, of why they're considering software-based solutions too, for just privacy concerns. So this all happens, they say, out of band of regular traffic, kind of happens on the side to try and reduce latency, and also reduce the need for making changes to legacy applications. Basically, if the browser supports it and the web server supports it, once this is done, it'll work. Otherwise, it'll default to the kind of old stuff. But they explicitly mentioned a few privacy considerations too. So these days, it's actually pretty easy for websites to track you as a user without necessarily knowing it's specifically Corey, but they can associate your device, its fingerprint, the extensions you have installed in Chrome. All of these can be fed into a pretty relatively accurate way of tracking a specific device. And then when you do log into something, then they can go, oh, okay, all of that is Corey, and now I know.
That's why Google Analytics works so well.
Yeah. And so Google's trying to make sure this doesn't become another opportunity to try and fingerprint a device that could break privacy. So for example, each session will get a unique key, and the DBSC does not enable sites to correlate those keys to different browsers on the same device. It doesn't leak any meaningful information about the device other than it supports the feature. And they said they're considering software keys for all users, regardless of hardware capabilities, so that the DBSC system won't let servers differentiate between different users based off whether they're hardware or software, because even that could be used as another fingerprint piece of information. So they've already actually deployed this in some cases. Anyone logging into their Google account from the beta branch of Google Chrome, that in some cases would be protected with this. And they've got a whole roadmap on their GitHub too for the next 8 releases of Chromium, of the new features and use cases they want to add. Technically right now, if you're one of those beta users, when you refresh, it has to do the whole dang thing all over again. So the next thing they're doing is actually supporting refreshing the web page in this, which is a useful feature to have.
Speed things up.
They'll have DevTools support, so being able to pull up DevTools to look at this more thoroughly in I think 5 or 6 releases in the future.
So my question is this, have they patented this, or are they open sourcing this? Because we brought up, Chrome and Chromium will have it, but what about Firefox, Opera, Edge? This seems like a industry-wide standard thing that we would really want on all browsers.
I can't remember the exact license, but it is open source licensed. It's not going to be patented. Their goal is to make this ubiquitous across the internet. They even talked about a few partners that are starting to adopt it, or at least explore it as well, like different IDP portals and other Chromium-based web browsers, like Microsoft Edge is looking at it. The cynical reality take I have on it is it's 98% of the internet uses a Chromium-based web browser, so it doesn't necessarily matter if it's open source because everyone uses it.
It's just kind of Chromium-based, isn't it?
Firefox is the only major one, and I personally use it to try and keep some of that market share, so we don't just have Google controlling the entirety of the internet. But technically, this is not a built-in thing to Firefox. They'd have to adopt it as well. But I think it's a great idea.
No, I think it's awesome.
Why the heck have we not been doing? Well, I know why we haven't been doing it, because TPMs up until recently weren't very common in consumer.
But if they find us, obviously a software version of this would still be good. By not having the TPM, it would be more vulnerable. There may be ways to get that key in a software version of it, but it sounds like they're trying a software version of it too.
And even if it is more vulnerable than using a TPM,
still would need local access probably, so they need that malware.
Way more difficult than what you can currently do right now.
So, yeah, absolutely.
Where literally you don't even need elevated privileges. You just need the privileges of the user. And presumably the software version would run as a elevated account that you'd interact with it through an API similar to a hardware one. So it would have some protections. Yeah. But, I mean, at the end of the day, I also feel like attackers will probably find some way to break or get around this, but it'll be significantly more difficult if that private key lives in a secure enclave like a TPM. Like,
absolutely,
that's specifically what they're designed to do.
Yeah, hide that private key. I do think it's going to ruin these threat actors. It will take some of their money away for selling cookies. Or session ID cookies specifically. The funny thing is the malware way, you know, the thieves that are packaging up and selling session cookies for certain domains, they're usually running a botnet, and the malware is grabbing them
continuously
from tons of computers. So they may not be able to sell the session cookies anymore, but if the way they were getting the session cookie is malware sitting on the computer, the malware still can locally spawn up a browser hidden and go to the site as you if there was a session cookie waiting for them, or if you open your own browser, I guess if they visually take it over, you might see. But the malware itself is still freaking malware on your computer, so it could still browse as you. Yep. So maybe instead of selling session cookies, they'll be selling
remote access
to the botnet.
This whole mechanism, it's used to get a new session cookie with a shorter lifetime, but there will still be a session cookie that in theory they could just continuously steal that as well too. Yeah. So it won't be like oh man, we've solved it. Yeah. No more session hijacking ever. But it does make it significantly
a lot harder. And I think as we like to talk about with the FBI, they will hurt the financial. This is one of the big money makers, I would assume, on the underground. So just cutting away those profits. You know, if is it not profitable for them to do it, maybe they'll go away. If it's harder and less profitable, go find something else.
And just for WatchGuard customers, it's something we're very aware of too. Yeah. And we actually just chatted with our head of identity and making sure that it is something that we're prepared to support for our own identity providers, like Authpoint, for example. Yeah. Really cool. Google's got a really aggressive timeline on this, which I like. Yeah. And I love that they're secretly already testing it. Yeah. Kind of like their post-quantum cryptography that they secretly test left and right too. It's good. And this will help a lot. Yeah. If you take nothing else from it,
it's going to help a lot.
Will help a lot. So cool, man. Well, sucks for me since I'm Firefox. I won't get a benefit from any of this.
I have a feeling that Google was a nice guy and they gave you an open source license. Mozilla seems to be all over. I bet Mozilla's probably already working on something.
I sure hope so, because I want to make sure that 1% market share stays alive.
I'm with you. I don't like big trusts, monopolies.
Well, that is the definition of Google, unfortunately.
I know.
Hey everyone, thanks again for listening. As always, if you enjoyed today's episode, don't forget to rate, review, and subscribe. If you have any questions on today's topics or suggestions for future episode topics, you can reach out to us on Instagram. We're at WatchGuard_technologies. Thanks again for listening, and I promise to never do that again.
Insta. You're supposed to say Insta if you're going to use that voice.
Catch me on Insta. All right.
Okay, I'm out.
Bye. This is too much. Perfect.